1, 2, 3, come on!
Come on, come on. Come on, come on.
Let's have perfect square, integer, and monomial. So before that, let's define an integer. So an integer, it could be 0, it could be positive integer or positive number, and it could be a negative number or negative integer. So let's go first to perfect square integer. So when can we say that an integer is a perfect square? So according to the meaning or a simple definition, a perfect square integer, it has two factors which are the same. So this time let's exclude or do not include 0 because 0 is automatically 0 times 0. We will have first 1 because 1 is 1 times 1. We have also 4 because 4 is 2 times 2. So we don't include 2 because 2 is 2 times 1. It is not a perfect square. And also 3. 3 is 3 times 1. So they are not included. Okay. Next 4 is 9 because 9 is 3 times 3. So according to based on the pattern, so if we do the pattern 1 times 1, 2 times 2, 3 times 3, so if we say 4 times 4, so the next perfect square integer is 16. And so on and so forth. Now, a perfect square integer can also be factored by a negative integer. So like 1, not only 1 times 1, but it's also negative 1 times negative 1. 4, it could be negative 2 and negative 2. 9, it can be negative 3 times negative 3. 16, it can be negative 4 times negative 4. So on and so forth. So because according to the rule, negative times negative is always positive. Right? Okay, let's proceed to perfect square monomial. So let's define a monomial. So according to the meaning, monomial is an expression which has only one term. For example, we have a, or you can say a squared, or you can say 2ab, or you can say 4a squared. Okay, so if I will write a plus 2, so this time this is not a monomial, so it is called a binomial because the two terms or the two monomials were or are separated by a operation which is an addition or plus, right? So when can we say that a monomial is a perfect square? So let's have first a, or we'll try a squared. A squared, if we will complete that one, there's 1 there. So don't worry if I will write 1 because 1a squared is equal to a squared. Okay? So a squared is just equal to 1a squared. So according to the rule that a monomial can be a perfect square if the numerical coefficient, so here 1 is the numerical coefficient. The numerical coefficient is a perfect square. Okay? And the exponent of the variable, a is the variable, okay? So the exponent of the variable, the exponent of the variable is even. Okay, remember again, the numerical coefficient is a perfect square. The exponent of the variable is even. Okay, let's rewrite 1a squared. So, the rule is the numerical coefficient should be perfect square and the exponent should be even. So based on our example 1a squared, 1 is a perfect square and 2 is even. So therefore this is a perfect square. So perfect square monomial. Another example, we have 4b raised to 8. So 4b raised to 8. So earlier we have 4 as perfect square. And the exponent of the variable b is 8. So this is still a perfect square monomial. Okay? Let's try 10m raised to 20. Okay. Let's go first to the exponent of the variable. So 20 is even, but earlier we don't have 10. So we will write again the perfect square integers. 1, 4, 9, 16, 25, 36. We have 49, 7 times 7. We have 64, 8 times 8. We have also 81 for 9 times 9, and we have 10 times 10, 100. So and so on and so forth. So 10, we cannot see 10 as our perfect square. So therefore, 10 makes the whole monomial or the monomial not perfect square. So this is not a perfect square monomial. Okay? Okay, let's have 25 n raised to 7. So is this a perfect square or not? So 25 is a perfect square. But the variable n has the exponent 7. And 7 is an odd. So therefore, 7 makes the monomial not a perfect square. Okay, let's involve two variables. Like we have 2a squared b squared. So the whole monomial, all the variables a and b have even exponent. But 2 is not a perfect square integer. So if you can see 1, 4, it goes directly to 4. So again, this is not a perfect square monomial. Right? Okay, let's try 100 m raised to 4 n raised to 3. Not a perfect square or a perfect square? So let's determine 100 perfect square. The variable m has the exponent of 4 even, and the variable of n has an odd exponent 3. So this 3 makes the monomial not a perfect square. Understood? Okay, let's try fraction or involving fraction. For example, we have 1, 9 a squared b squared. Okay, 1, 9. So don't worry about that fraction, because if the fraction or the numerator and the denominator has perfect square numbers, so it is a perfect square. So like 1. So if you can see 1 is a perfect square, 9 is a perfect square. So this fraction 1, 9 is a perfect square. Now we have a squared and b squared. So all the variables have even exponents. So this is a perfect square monomial. right? We can also have m squared over 64. So m squared, the variable m has the exponent of 2, and 2 is even. 64 is a perfect square. So therefore, this is a perfect square monomial. Okay, we have last example. We have 7 over 36 b raised to 8. Okay. In the example, we have fraction again. So 36 or 7, here you cannot see 7. So therefore, this 7 makes automatically the monomial not a perfect square. So not a perfect square monomial. Now, it's time for you to identify a perfect square monomial. So, which of the three numbers or which of the three items is a perfect square monomial? Please comment below.
1, 2, 3, come on!